Well, it appears from their press release and from material in the media that they actually examined the collapsed structure after the collapse, and they found that a lot of the reinforcing steel in the concrete was corroded. I presume from that they've made the statement, and that has therefore linked corrosion with the structure. Now, the question to ask here is, if the material that's going to be stored in the silo is, for argument's sake, coal, and if the coal has got corrosive materials in it, or it gives off corrosive materials, or corrosive gases, for argument's sake, and if the coal is going to be wet, then what should have happened was the reinforcing steel inside there should have been hot dip galvanized. And all of that goes into the design. Now, of course, I haven't seen the design, so I can't comment on it. But when the investigators go to look at it, and that's what I do as a corrosion investigator, we will look at the original design drawings, look at all the design of the materials, the concrete mixing, the records, the quality certificates, whether hot dip galvanized reinforcing steel was used, etc. Silo design is a specialized area of engineering and engineering design, and it's possible, I'm not saying it is, but it's possible that whoever designed it wasn't aware of what could happen within a silo. For argument's sake, if this is a silo and there's material filling the silo, if there's material flowing out the bottom, sometimes what happens is the material forms an arch and all the material falls out the bottom, and the material that's left loads the side of the silo and it bulges. The silo is not meant to take that sort of pressure, and the wall can crack. If the wall is weakened by some, say, corrosion or cracking in the concrete, then you will have a collapse or you will have a cracking problem. What they'll have to do is make sure that the silos are designed to cope with the kind of coal they're now mining. And during that famous scandal in 2006-2008, there was comment that poor quality coal had been supplied, that there was stone and grit. That could have had an impact on the silo, because if the coal falls into the silo from the top, somehow the coal's got to be got into the silo. And although I haven't seen the design of the silo and how it operates, it's possible that the rail cars come over the top, or a conveyor that pours the coal in this way, or the rail car comes like this, is tipped over and the coal drops in. If the coal is very abrasive, it would have abraded away the inside of the wall. Now, if you're operating for 13 years, let's say that continuous abrasion, no maintenance, no checkups, that continuous abrasion could have removed weakened concrete, or it could have been just normal concrete. It could have removed the cover until it got down to the reinforcing bars. And then the bars would have been exposed to the corrosive atmosphere from the coal. They in turn would have corroded. Their volume increases and they would crack the concrete. And then one day, as happened on Saturday, the whole thing just comes apart. Accidents do happen. Silo collapses happen very suddenly. Silos are special end structures. Go and check every silo, do non-destructive testing on every single one of them, and do a risk profile. Look at the probability of failure and the consequences of failure. Because, as I said to you earlier on, 30 years ago, if a silo failed, it would have had no impact. You wouldn't have even heard about it because the power would have continued. But when the margin of power supply is so low and a silo collapses, cuts off all the supply to that power station, and in this case they dropped from 3,800 megawatts down to 600 megawatts. That 3,000 megawatts loss exceeded the spare capacity in the system. So the consequences of a failure there are enormous. So now they need to look at their whole power supply system and say, probability of failure for whatever reason, consequences of failure. And in their case, almost everything they do has a severe consequence. So the first thing that should happen is they should have regular non-destructive testing and inspection of all their concrete structures, their tall stacks and the silos. From that report, they'll be able to say, well, this silo is not cracked. There's sufficient rebars. It's called reinforcing steel bar. The short term is rebar. So there's sufficient rebar in the structure. The rebar's not corroding. There is no carbonation of the concrete. There's no chloride in the concrete. They can say, fine, that structure's okay. We'll come back in a year's time, for argument's sake, and then move on to all the structures. Then they could look at the probability of failure and say to themselves, right, this structure's got a problem. We must plan a maintenance for it. or this one is in urgent need of repair, we've got to stop it. Make an alternative plan, route the coal movement at the power station round it, and then get in there and do a repair. Then get consultants in to say, right, this is the state of the silo, and this is how you've got to fix it.